Don't you like?
So nitrogen, and then what? Oxide. Now, a couple people asked me this at the start of doing this about whether or not you always used a Roman number, or if you did. If you can't remember that, don't worry about it. Look it up on your blue card. Look up nitrogen. Does it have more than one number listed? Yes. So you know you need a Roman number, okay? Now, was it reduced? Okay, so you looked up oxygen. Most of you probably already know oxygen's a 2 by now. Is there a 2 right there? No. So you know you got to multiply it through N2O6. You don't do anything with this formula except figure out that the 6 came from what? The N. So nitrogen is nitrogen 6. That's all that formula is used for. You don't do anything else with it except figure out that's the Roman number. Other than that, that's junk. Okay? That's all it's for. So when you do the next one, Cl is chlorine. F is fluoride. And then is chlorine going to need a Roman number? Look it up on your card. How many numbers does chlorine have listed? Yes, it's got a whole bunch of them, right? So it's got to have a Roman number. So was this one reduced? Fluorine has a 1. What's right there? So if it is a 1 and it's still a 1, was it reduced? No. So it wasn't reduced. What number came from the chlorine? So we put Roman number 2 right there. Because it wasn't reduced, we don't have to go through that multiplying process to figure out what it used to be. Okay? And the last one, P is what? Phosphorus. And then O is oxide. All right. Does it need a Roman number? All right. Now, O is -2. Oops. Put that back where it was. All right. So O is a 2. Is the 2 there? Yeah. So was this one reduced? No. So we don't have to worry about multiplying through it. What number came from the P? So we just put a 5 right there. Okay? That's stock. Everybody with me on stock? Now, old system. Older prefix system, we don't do anything with, yes ma'am.
What is the difference between that and what we were doing before just looking at the card?
Nothing.
Because I was confused. It was like
it's the same
thing. And then
it is the same thing. The only difference is some of those have been reduced. Okay? It's identical.
Like for number 1, how there's a 3 out of 0. I mean, you got an O. Okay, since the oxidation number for O is 2, I would put the 2 back up there and multiply it.
Exactly. Now, when we did it with ionic, at first, I just tried not to give you any that had been reduced. So now, I would not be as kind, and I might give y'all something like that. Okay, so how would we write the name for that? Okay, lead oxide. Okay, I heard we need a Roman number. I'm good with that. And what is the Roman number? Because now I would expect y'all to know, okay, oxygen has a 2. That 2's not there, is it? So I would expect y'all to still be able to use the same skills and multiply and say, okay, that was the original formula, and that 4 came from lead. This is an ionic compound. I was careful not to give y'all those when we started ionic compounds because y'all didn't have those skills yet. Now that you have the skills to do that with covalent, I will put that back in with ionic. Okay, I'll overlay those skills on top. But the process is the same. Nothing's different.
So if they don't give you an oxidation number, like in the formula, I don't know if that ever happens. You choose the first positive number.
I have to give it to you if it's positive. That's why you have to tell me the Roman number in there. Because if it's a positive one, you either have to tell me or I have to tell you. because otherwise you don't know which one to use.
But the second one always should be negative.
Right.
So the first one will always be given to you?
Of course. Otherwise, you wouldn't know which one to pick. Okay? That's the whole point of that Roman number, because you have to tell me which one, or I have to tell you which one. Whichever one of us is writing the name, we have to tell each other which one to use. Okay? So any of those elements that you look, that you say, oh, it's got multiple positives, we have to write a Roman number for each other to know which one to use. Okay? That's the reason for it in the system of naming. Does that make sense? Okay. Who else has a question? Everybody else is okay. Devontae's asleep. He's had a rough night. What did you do last night? What time did you go to bed? Like what? Were you doing homework till 1? Oh my. Hope it wasn't mine.
Human deal.
Huh?
Human deal, I bet.
Okay. If it was at my house, we were doing a push. All right. So if we look at doing old system, we only look at the what? What do we do for old system? We only look at the what? The numbers, the subscripts. So how many are on N? So do we put a prefix? No. So we write nitrogen. And how many O's? 3. The second one always gets a prefix. So we write tri and then oxide. All right, number 2. Chlorine. And then difluoride.
So you don't change it at all?
Change what?
Like the numbers?
No, you don't backwards crisscross or anything. There's no switching. There's no nothing. All right. And for the third one, we have a 2 on that first element. So we do what this time? Diphosphorus. And then pentaoxide. Okay, no switching. It's just straightforward. Whatever number becomes a subscript, or the subscript becomes the prefix. Now, for the bottom, again, there's no crisscrossing, no oxidation numbers. These prefixes tell us the subscripts. So since phosphorus has nothing here, that means phosphorus has a what? It has a 1. Pentaiodide means iodide has a what? A 5. And I'm just going to take the 1 off because we don't usually write it in the formula. All right. Diantimony. Antimony is SB, and it says di, so that tells me it's a what? A 2. Oxide is O. Penta means what? 5. Got it?
Will the second element always have a 5?
No, I just happened to pick 2 that had penta on it. I mean, if I had this and it said tri, then we would have had 3. Okay. What else? Yeah. You sure?
I flipped the numbers again.
Oh.
I guess.
There's no crisscrossing in this, and that's the challenge and why I hate doing old system, because y'all are so ingrained to crisscrossing with stock, it's hard to remember that old system does not do that. Stock crisscrosses, old system does not.
So what is the second one supposed to be? SV205?
Yeah.
And do you simplify if the numbers are like?
In old system, no. Old system does not simplify either.
Or like writing high?
Yeah, so if you had, let's say, di, nitrogen, tetra, oxide. So they gave you that. Dinitrogen would be N2. Tetraoxide is O4. You would not simplify that either.
So
Okay.
the only way you know not to simplify it is if it has this prefix.
If it's an old system, yes.
Okay.
Yes. Stock would simplify, old system does not. It's one reason we don't use old system very much. What else? No way? You want to do homework or you want to wait since the quiz is on this? Okay, because this is the quiz. Being able to do what's up here. Quiz is not all mixed up.
Is it homework?
Nope. The homework is everything all mixed up. Ionic and covalent all together. The quiz is that. Just covalent. We just went over the quiz. Okay. I mean, I'll do it either way. Y'all tell me. Okay. You can have your blue cards today.
Are you sure?
There are no acids on it.
Oh my god. See, and I was getting ready for that.
There are acids on the test. There are no acids on today's quiz.
You know, I'll take that.
Hey, I'm fair. I told you, no acids today. There is a typo I need to tell you about, though. I got to misspell. When you get to number 10, it says carton. It's not carton. It's carbon. Okay, carbon, not carton. We'll change the T to a B. There are no elements named carton on the periodic table. Plain old carbon. So that y'all have a time limit, let's say 9 o'clock. That's 15 minutes. That should be enough time to answer these questions. Maybe you were still working, just out of curiosity. Okay, that's fine. I was just curious. All right, it looks to me like Caroline is done. So if she's done, where are the rest of us? Because she's usually my threshold marker. Not that I'm picking on you, but you're usually my signal. So are we done? Yes? Okay, that's right to the front. And I can work on what I'm trying to figure out later. Because I think I'm going to be built next. So this is beyond my skill level. All right, now we can do homework. All right, one more. Let me find mine. This is the one that starts with sodium thiosulfate, right? Hey, I actually have the answers written down. Go me. Got to do it for the one that we're going to use for test review. Those. This one. All right, let me make this bigger. That big enough? Now, there are the answers. To the top half anyways. Questions? Anything? There's some erasing going on, so I know some people got some things wrong. Questions about anything that you got wrong you want to ask about? This is going to be Tuesday, by the way. No, it won't. They're not here Monday. It'll be Wednesday. It'll be Wednesday. Sorry. Just be Wednesday. I was thinking we're here Monday. So what now?
For number 7, the triiodide,
Uh-huh.
drop the I in iodide. Would you count that?
No, I would not. I would not. For some reason, that one we typically leave both eyes. We just don't leave both O's. I don't really have an explanation as to why we do. Spelling was never my strong suit, so I don't really have an explanation grammatically why we keep the 2 I's and we drop one of the O's. Anybody have a question in 1 through 10? Okay.
5.
5? All right, so in 5, I don't know what 5 is.
I think I just mixed up the numbers.
1, 2, 3, 4, 5. So that one? Okay. So you have, I can just do that. So you're okay with Fe's iron, and you found citrate, okay, right?
Yes.
Okay. So the 3 came from the citrate, so that's not been reduced. So did you write iron 3?
Yeah.
You went straight down instead of backwards crisscrossing, so that 2 came from the iron, not the 3.
Well, I don't know. I mean, I crisscrossed it and I have written down it, and then put the FE too. So I don't know what it is.
I don't know what you did either. Oops, that's too much. Let's see, I might be able to make that a little bigger. All right, how about, no, that's not gonna work with that. I don't need that to be there. How about that?
I know you have like 4 with the parentheses and the one with the NH4, C2, H3 one.
Uh-huh.
Like, if we always put the parentheses, will it be wrong?
Nope. It's only wrong if you need the parentheses and they're not there. Okay, so like this one. See how you have to have the parentheses because there's a 3 outside? If those parentheses are missing, that's wrong because they're needed. But like here, they're optional because there's a 1 outside. If you just leave the parentheses like that, I won't mark it wrong. Okay? I just want you to get used to the idea that sometimes they're not going to be there. All right. What about those 10?
Number 19.
Which one?
Number 19.
Is everybody checked so I can take it down? I can work better on the smart board than I can on this because I can't write on pens. It doesn't have enough graphic crap memory stuff in the computer. So everybody's okay with the answers? I can take them down? Okay. That's fine. I just want to move the answers and get rid of this so that I can write on the smart board. All right, so you wanted which one?
Number 19.
Number 19. All right, give me your answer. So number 19 is chromium. All right, so we have Cr. It has Roman numeral 3, and then it says hexachloroplatinate. All right, hexachloroplatinate is the name of a polyatomic ion. It is not old system naming, okay? And sometimes that's one of the ones that'll throw people off because it says hexa, and they think it's old system naming, but it's not. So when you look it up, it's at the very bottom of your blue sheet, okay? And hexachloroplatinate is PTCl6. It has an oxidation number of a -2, okay? So put it in parentheses. The 2 is coming over here, and the 3 is going over there. So end up with Cr2, PTCl6, and a 3. Like that. Does that make sense? Okay. Did you say, Almaja, you had 2? Which ones?
13.
All right. 13 is another one just like this. Dichromate is not old system naming. It's a polyatomic ion. Okay. So 13 is antimony. It has a 3 at the top. Dichromate is Cr2O7, and it has an oxidation number of 2. It's a particular polyatomic ion. It's about, I think, about halfway down, maybe not quite. Put it in parentheses. Bring your 2 down. Bring your 3 down. So you get Sp2Cr2O7 and with a 3. Okay, and which other one? Which one? 20. All right, see how it ends in IDE? IDE tells us what? Binary. It's only going to have 2 elements. Okay, so you have calcium, which has a 2 on it. Nitride means it's in, and it has a 3 on it. Okay, so the 2 comes down, and the 3 comes down. So you get Ca3N with a 2. That makes sense? All right.
If we don't know if something is old system or polyatomic, what do we do? Like check the side first?
I'd check the side. There's only 3 of them. The 3 that you're going to see, and the one that's most common is dichromate. You're going to see it often. Okay? That's the one you're going to see most often. The 2 that you will see very rarely, and probably not beyond this test, okay, but you're going to see that a lot, are diphosphate and hexachloroplatinate. Okay. Those are the only other ones you're going to see that have a prefix in their polyatomic ions. But this one you might want to learn to recognize is not old system because you're going to see it all the time. These 2 rarely pass this test, okay, because I almost never use those. Dichromate, you're going to see a lot when we get to balanced equations towards the end of next week, okay, because we'll test Wednesday and we'll do some math most of next week. And then early into the next week, we'll start equations, and you'll see dichromate a lot. Other questions? Anything? All right, y'all don't have calculators, so go grab a calculator and your periodic tables. We're going to do math for the rest of class. Because we're going to finish what we need. So Tuesday we can do some review and then test on Wednesday. And I did tell you my magnesium came in, right? Yeah, so we're going to do a magnesium lab that we weren't able to do last year because I didn't have any. And we're going to do our first lab report with it. I haven't decided. It probably won't fit in next week, so I'm thinking the week after.
Right now, we're doing that issues talking about yesterday. Yeah, I have to do it right now.
Oh, we're gonna review formula mass, and then we're actually gonna add it to something you already know how to do. Today should be easy math because we're just adding on to something you already know how to do. Today should be pretty easy. Should be. You remember the quiz we took where we did grams, moles, atoms? We're doing that today. You already know how to do that. Okay, we're going to review how to do that then. All right, so yesterday we were talking about formula mass. What was another name I used for formula mass? All right, we used molar mass. What was another name? Molecular mass. Okay, gram formula mass. Okay, all of these names okay, all of these names, okay, every one of them just meant yesterday the mass of a compound. And you already have this written down, so you don't need to write it again. So, I told you yesterday that we were able to find the mass of an element on the periodic table, but now y'all are more sophisticated. Y'all are going to be working on your sophistication level all semester long. So we can find the masses of elements on the periodic table. Now y'all have learned to write names of compounds. So now we're going to learn to do some math with some compounds. So yesterday we learned to find the mass of the compound using formula mass. So we did sodium sulfate yesterday. So let's do a different one. Let's say that we have aluminum. Let's do dichromate. Okay? Since we just had that polyatomic ion up here. All right, so if we have aluminum dichromate and we want to find its mass, all right, we said yesterday we needed what two things to do this? Periodic table's mass, and what else? I heard somebody say it. Number of atoms, okay? So, I can't remember, but I was thinking it was Antoine who said we had to know which elements we had, okay? So, which elements do we have? We have aluminum, chromium, and oxygen. Okay, sometimes we'll have 3 elements, sometimes we might only have 2 because it'll be binary. But I wanted to do one that have parentheses today so that we can make sure we handle the parentheses correctly. So, how many aluminums do we have? We have 2. Now, everybody knows parentheses mean what in math class?
Multiply.
And distribute. So, when you have parentheses, make sure you multiply and you distribute. So that 3 is going to multiply to the O and distribute to the CR also. It doesn't just go to the O, it goes to both of them. So how many CRs do we have? 6. And how many O's do we have? 21. Now, all you have to do is look up the mass. I've been telling you now for, I don't know, at least a week, maybe 2 weeks, that our answers are going to vary here. And Carolina's going to drive me insane. I'm just picking on her. Because she's going to ask me 100 times, is my answer okay? Because our decimal places are going to vary. At some point, our whole numbers are going to vary because I'm just going to take a shot in the dark, but she's probably going to copy every number down off the periodic table. It is A-okay. Some of you are going to round to one number behind the decimal place on the periodic table, which is what I do. When I work problems on the board, I round the whole numbers because I can do a lot of math in my head if I round the whole numbers, okay? I can't do any math in my head if I use decimal numbers. I'm terrible at decimals and fractions. I'll be the first to admit that. I thought middle school was going to kill me with decimals and fractions. Still terrible at them. So when I work math problems on the board, I'm going to round that to 27, 52, and 16. Now, when I work an answer key on the test, am I going to do that? No, but some of y'all are still going to do it that way. Is it okay? Yes. So, are our answers all going to be the same? No, they're not. They should be very close, though. All right? So, when I add this up, the answer is going to be in the same ballpark. So, if Caroline takes them out, the 2 decimal places that are on the periodic table, and I use whole numbers, her answer is going to vary slightly. Is that okay? Yeah. Yes. Okay? So no one has to nag me 800 times. And I'm going to try very hard not to lose my patience. And it's good that y'all are in first period. I'm much more tolerant first period. It's only fourth period that, you know, I tend to lose my patience with that. Now, yesterday I just did this and I didn't really make sure everybody was with me. What do I do with those 3 numbers? Because I'm thinking it was Diamond who asked me this. You add them, okay? You take all 3 of those numbers and you add them up. So 336 plus 312 plus 54, and you get 702. And what unit did we say we put on the end of them?
AMU.
You can put AMU, or if you want to take the shortcut, you can put what? Or you can write U. Okay? Either answer is fine. And that just stands for atomic mass units. Any questions on how to do that? Yes? No?
Will this be on the test?
Of course it'll be on the test. That's a 4-point question on the test. You'd be surprised how many people don't know how to work it on the test, too. And then when I give it back, they're like, that's all I had to do? I'm like, yes. But you know he's going to get that wrong, right?
I don't know. Depends if it's a word problem. Can we try one by ourselves?
Sure. I'm all about letting y'all do something by yourself. How about y'all do SiO2 and we do calcium perchlorate.
Is that C10 or CLO?
ClO4. Any of y'all who are friends with Karina, her grandmother's not doing well, so if you're thinking about her, reach out to her. All right, we got them done. Need more time? Where are we at? What'd you get for first?
60.
So, are we all in the ballpark of 60? You might be at 59 point something, you might be at 60 point something, but somewhere in the ballpark of 60. Yes? All right, what'd you get for the second one? All right, so we're all in the 238 range. 237 point something, 238 point something. You know, I gave varying answers there and gave you a range. Okay, if you're in the range, you're okay. The reason I said that is some of us took all the numbers on the periodic table. Some of us probably used whole numbers. Okay, we're not all going to get the exact same answer. But what we're getting ready to do next, it's going to vary even more, and that's okay. What's wrong? What? Yeah, that don't look that good. This one might need to go see Mr. Butts. He does. All right, let me do this one. We've got to make a trip down there. All right. Next, the last thing we're going to do today, we're going back to mole conversions because again, we are more sophisticated. Now, when we did mole conversions last, that was what, a week and some days ago? Y'all learned that we could go from a gram to a mole to an atom. Okay? And an atom was only for an element, right? But now we're more sophisticated. We can do whole compounds. So we need to add to this chart. Yes, we do. It's not hard. Y'all are making a mountain out of a molehill here. Now, come on.
That's not
We're not even going to make it longer today. Okay? So we're going to add a molecule here. And we're, except I didn't spell it right. And we're going to add a formula unit here. Now, the only thing that makes this different in terms of how this works. Is a molecule is for covalent compounds, and formula units are for ionic compounds. It doesn't affect the math at all, okay? Doesn't affect the math at all. Now, for our conversion factors, we learned that 1 mole was equal to what?
6.0.
Okay, and that was equal to atoms. Now, it's also equal to molecules and formula units. Yes, it's a lot like a dozen eggs. If I sent you to the store and said, bring me a dozen eggs, all would appear with 12 eggs. But I'm not a big fan of just having eggs, right? All right, I could send you to the store and you can bring me a dozen donuts, and we'd have how many? Or a dozen cupcakes, we'd have how many? So this is your eggs, this is your cupcakes, this is your donuts. They're all the same thing. They have the same what? They have the same number, they're just different things, okay? This is for an element, this is for a covalent compound, this is for an ionic compound. Does it work different in terms of what the number is? No. If I sent Alex to get me eggs, Lolly to get me the cupcakes, and Denasia to get me the donuts, they're all coming back with how many? 12. If I sent Antoine to get me the atoms, Jada to get me the molecules, and Max to get me the formula units, they're all coming back with how many? 6.022 times 10 to the 23rd. Okay, they're going to need a bigger bucket, but that's how many they're coming back with. Okay, molecules are covalent, formula units are ionic. Okay, you don't even have to worry about that for the math calculation. Okay, all of these are equal to that number. All right, now the second thing, 1 mole is equal to what? What was the other thing it equaled? Atomic mass in grams. Now, we're more sophisticated now. It doesn't just equal atomic mass. What other kind of mass can it equal? Formula mass. Good, Almaja. Okay, it can also equal formula mass. All right, and you have the right idea when you say compound mass. All right, you just use the wrong name, okay? You can say formula mass, you could have said molar mass, you could have said molecular mass, but it is the compound mass's total mass, okay? Now, does anything change up there in the flow chart? No. So up here, where we wrote this stuff down, let me find a color we haven't used up here. Let's use this one. No. Let's use purple. All right, for gram, where are we going to find the number for the gram? Where'd you find it when we filled in the chart the first time? We're still using the periodic table. What number goes beside moles? 1, because we haven't learned to balance yet. Not going to do that next week. It'll be the week after. So we're getting ever so closer to being able to change those moles from 1. Getting closer. And then atoms, molecules, and formula units are still going to get what number beside it? What's the name of that number? That man is rolling in his grave right now. Avogadro's number. It's Avogadro. There's no avocado in there. That's a fruit. All right, Avogadro. Amadeus Avogadro. Okay. Okay, not everybody can be a pile. I get it. I dropped my maiden name when I got married. I kept my middle name and dropped it. Everybody looked at me like I was crazy. All right. Everybody got it. So let's say that we do a problem and it says how many moles of calcium sulfate are there in 12.54 grams. Now, that question appears to be very similar, does it not? Looks very much like what we did about a week ago. There's only one difference. A week ago it was an element. Today it's a compound. That's the only difference in the question. Right? It's the only difference. So, what did we do with that? We drew a chart. Still drawing a chart today. That chart's going to be a tad long. Okay, what goes on the top line? 12.54. That's our given data. Given data always goes on the top line. The unit you don't want goes where? On the bottom. So grams goes on the bottom. Now, you can either look at the flow chart or you can just ask yourself, what do you want? It doesn't matter to me which way you do it. If you look at the flow chart, we're starting here in grams. What do we have to go to from a gram? To a mole. Or you can say to yourself, I'm in grams. I need to go to what? Moles. Now, again, moles, guess what beside it? A 1. We haven't learned to balance equations yet. So every time we get moles, we put a 1 beside it. Because we're getting there. Not there yet. Now, every time we do grams, what do we just write on that board back there? Grams always comes from where? Periodic table. Now, before, we'd have looked at the periodic table and we'd have said, okay, we got such and such element. And we'd have written it in. Now, we don't have an element. We have a what? We have a compound. So what do we have to do when we have a compound? We got to find the formula mass. That's that new skill we just learned. So we say, how many calciums do we have? How many sulfurs do we have? How many oxygens do we have? Mass of calcium is? Mass of sulfur is? I'm just going with 32. It's faster on me. And oxygen is 16. You'll learn that one fast enough. 64, 32, 40. We're going to have 6. We're going to have 7 and 6. It's going to be 1,336. Okay? Hence the reason I don't use the decimals. All right? So all we have to do is what? Divide. So 12.54 divide 136. Now, when I get this answer, this is different than formula mass because what I give you in the question this time. A number. So what do I have to have here? Of significant digits. See, if I cruise back to this question, did I give you any numbers? Didn't matter how many significant digits you had because I didn't give you any numbers. So you could have had 5, you could have had 4, could have had 3, it didn't matter. But here, I gave you a number in the question, so you have to have the right number of significant digits. So how many numbers do we need in our answer? 4. So I have all these numbers on my calculator with a leading 0 of 922, and then I have a 0. Is that 0 significant? Yes, so I can keep him. All right? But this one is a what? So it doesn't count. And my unit is moles. Questions about how I did that? Yes, no? It'd be a -1. Then it would be fine. Remember. All right, I'm going to talk about this again. It has to be in the ballpark. So as long as your significant digits are fine and you have 4 significant digits, then it's good. Okay? That's one reason why these are full response tests, so that I'm grading your work. Okay? If there's no work, you get no credits. Everybody hear me say that?
Yeah.
Yes.
If she goes to 1, then what would it be?
Because she's saying if she had 0.09221 moles. Yes. I mean, even if you had like 0.09345, I'm good with that. This is still the same answer. You're still at 0.09. All right. Your number might not be exactly the same as ours. So your answer can vary. Yes, ma'am. No. You add 9.220 times 10 to the -2 moles. My brain works pretty quickly. Okay. I've done this long enough that my brain will switch between those two notations almost instantaneously when I'm grading your test.
So would 0.1 be too far off? Since it's
0.1 is rounded up a whole lot.
Yeah.
Don't round quite that much. Okay, y'all have some serious issues with rounding if y'all rounded that to 0.1. Okay, that I'm going to take off for. I'm going to put -2 calculator error. All right, questions? All right, let's do another one. All right, how many grams are there in 7.82 times 10 to the 24th molecules of CO2? All right, so what are we putting on the top? Where do we start? What's our given data? Molecules. So 7.82 times 10 to the 24th. Now, if you want to abbreviate molecules, the abbreviation is MOLC. You will not see me use that abbreviation very often because what do people confuse it for? Moles. But you can abbreviate it MOLC if you want. All right, what goes on top? From a molecule, you have to go to what? Moles. Remember, I don't want you skipping moles because their moles always going to be a 1. No, they're going to change. If you get used to skipping moles, you're going to be in deep doo-doo when they're not 1s anymore. You got to have moles in there. Plus, if it's wrong, I won't give you any partial credit on the test. All right, so from a mole, what do you put on the bottom? And then what do you put on top? All right, so what do we all know goes beside moles? We know we have 1s. We haven't learned to balance. What number goes beside molecules? Molecules are just like atoms. So molecules will always get what number? Avogadro's number. Okay? Now, grams always come from where? Periodic table. So what did I give you up here to find off the periodic table? CO2. So how many C's are there? How many O's are there? Carbon has a mass of 12. Oxygen is 16. So 1 times 12 is 12. 2 times 16 is 32. Add them together, we get 44. So the 44 goes where? For the grams. And again, just to review, you can choose whether you want to divide first and then multiply. I multiply first and then divide, but you choose. It doesn't matter which one you do first. I got 572. You can round to 573 based on the decimal if you'd like. Anybody else get that?
I got 571. I did too.
Okay. I may have put a number in wrong. Of course, I also use whole numbers. So 573, 571, all in the range of what I would accept. Okay, you see how I'm talking about numbers may vary slightly. They're not necessarily going to be the same, depending on how we round. Now, when I do answer keys, I don't round the whole numbers in my masses. I use the decimals. I just do whole numbers on the board because it's faster than my math. Questions? I need help from you.
What? Not on this. I forgot all that.
I don't know all that. I need help filling out a referral. I can't figure out how to use the form. When I go into it, it either gives me editing rights or the one I tried to pull up where it said downloadable or it was Miss Ford's.
Okay, email me the referral
Okay.
and then we'll figure out what's going on.
Okay. I'm like, I'm not usually this tech stupid, but
It's probably something with the system not to.
okay.
We'll go with that.
Okay. What? No, I don't. You know, but last night I was trying to fill it out and it kept giving me boxes to change the form. I was like, I want to edit the form. I just want to fill out the form. It's just like, I'm not supposed to be able to edit the referral form and change it. Could have last night, I guess. Just jacked it all up.
Which little bit? So we'll here.
Yeah. All right, so questions.
I got 571.
It's fine if you got 5 seconds. I could have punched it in wrong, for all I know. I just didn't go back and punch it in again. I was just lazy. Other questions? Do we need to do another?
No.
No, you think you got it. So we can practice. What?
Yeah, we'll learn.
Okay. How about I put it up there and y'all do it?
Yeah.
Okay. Y'all only did 2 with me. All right, how many formula units are there in 15.82 grams of aluminum sulfate? I picked that one because I knew the mass of the compound. I'm not going to have to add it up. Because I'm just lazy that way.
Where are the abbreviations for formula units?
You can write F unit if you like. Please don't write FU for obvious reasons.
So did they already give you the mass when they gave you that number or no?
Nope, I just do that off the top of my head.
But like, do we have to figure it out for the mass?
Do what?
Like, would we have to multiply and find the mass of each number
Uh-huh.
for this one?
Uh-huh. Yeah, I just already knew that one. That's why I picked that
Perhaps
particular
a
compound.
15.826.
That's your starting data.
But don't you have to find another number?
Yeah, for aluminum sulfate. Are we done? All right, then let's talk about it. So, what do you put on the top? All right, so 15.82 goes on top because that's your given data. What goes on the bottom? Okay. So, Jay, look up here. Look the wrong way for me. When you're in grams, what do you got to go to next? With me on that? So, we're going to put moles on top. Now, if we want moles, we're done. Did I ask for moles? So I got to draw another section. So what goes on the bottom? All right. And what did I ask for in the question? So I'm going to put F unit there just so we can write the shorter version. All right. What number always goes beside moles? Now, formula units is just like molecules and atoms. So what always goes beside formula units if it's just like atoms? So we put that beside formula units. And then for Rams. Rams is always going to get a what? So we're going to have to add that up. So we got to take this thing, and we got to add it up. So AL has how many? S has how many? And O has how many? So times 27, times 32, times 16, 54, 96, 190, 96, something like that?
92.
92. 342. Okay? And so now we can multiply and get the answer. That's going to be 2.78 times 10 to the 22nd formula units. Say what?
7.5.
Oh, I need 4? I didn't even look. I just looked at my calculator. Needs a 5 or a 6. Mine had a 5 there, but I can probably round it to a 6. I didn't look to see what was behind it. Questions? Want to try some? See what we can do? It's on the test. They're free response. They're 4 points apiece. Okay. I'd rather not be depressed after a grade y'all's test on Wednesday. Just saying. Oh, we only have 5 minutes left. Okay. I think there's only 3 in all. I'll check for me. Can't really tell how many papers I'm handing out. I can't do it very well. Website. All right, everybody got a paper? All right, we're going to do question numbers, let's say 1A. Let's do 5B. Let's do 6B. Let's do 7B. 8B, and 9B. That's only 6 questions for homework. That's not bad. 3-day weekend and only 6 questions.
Or do we have to know?
Yeah, you can go to the bottom of your notes. If I check homework, you can show it to me in your notes just as easily as you can show it to me there. I don't care where it's at. All right, you guys go put your calculators all that way, so you got them.